Okay, earlier in the earlier in the course, we did this Desmos lab where we sort of dragged this point around on the curve and we looked at the relationship between the slope of a function and where it was increasing or decreasing. So if we think about in this particular picture, drag the black points to show another interval where the tangent lines have positive slope. Here, like right, the blue has a positive slope, so that means the derivative is positive right here. And note that the function is increasing, right? So if you recall this Desmos lab, the idea was that if f, oops, sorry, my computer is thinking for a second. If f is increasing, that's going to lead to f prime being positive, right? And in fact, vice versa. If f prime is positive, that will tell us that we know f is increasing. And so, or another way to write this is f prime being positive, f prime being greater than 0. If f is decreasing, that's going to lead to a negative derivative, right? Or f prime would be less than 0. But also, if the derivative is negative, that tells us that the function is decreasing. So that relationship we've already seen, and I hope that that makes sense to you. So if the graph is going up, then its slope is going to be positive. So just to summarize in sort of a box format here, we have the same information. If the derivative is positive, the function's increasing. Where it's negative, it's decreasing, etc. Let's do an example of why we might care about something like this. So we have the U.S.'s gross savings as a percent of gross domestic product can be approximated by this function f of x equals this cubic here. And this is for values of x between 5 and 10. And so this is a model that will only last for these 5 years, but that's a pretty good model. X equals 5 corresponds to the year 2005. So the question is to describe where this function is increasing and decreasing, and then what this would mean in the context of the problem. So this makes sense that we would care about something like this, right? We want to know where it's increasing and decreasing. We want to know when this gross savings as a percent is going up or going down, when it's an increasing or decreasing. So if we're going to do that, we're going to talk about increasing, we're going to want to look at its derivative, right? So f prime, if I take the derivative, and again, you maybe want to pause this and take the derivative by hand. So we're going to get 0.9x squared minus 13.6x plus 48.6. So let's just take note of the fact that the derivative is quadratic, and so we do know how to solve quadratics completely. Okay, so let's make note of something. If I have a function that's bigger than 0, if the derivative is bigger than 0, it's increasing, the function's increasing. Let me say that carefully. Where the derivative is bigger than 0, the function is increasing. And where the derivative is less than 0, then the function's decreasing. And happening somewhere between switching from negative to positive, of course, the function is 0, right? You can't have a derivative somehow jump from being negative to jumping up to being positive. It has to pass through 0. So what we really want to do is solve the equation, where is this derivative equal to 0? Where is it switching from negative to positive? And so this is a matter of just using quadratic formula yet again. So we would have negative b plus or minus the square root of b squared minus 4 times a times c, all that, all over 2a, so 2 times 0.9. Okay, so we get two values. One is approximately 9.312, and the other one is approximately 5.79. We'll go with 9. Close enough. Okay, so how do we interpret these answers? Like, what's happening here? So let's think about what this quadratic looks like. It's a quadratic, it's a parabola, its leading coefficient is positive. So I know if I sketch this, it's passing through at 5 point something and then again at 9 point something. That's where it's passing through the zeros. So the zeros are passing through a little bit bigger than 5 and a little bit bigger than 9. I'm going to miss. And we know it's opening up. So this is not my best curve at all. Let's pretend that this is a parabola. So please ignore my messiness here. This is f prime, not the original function, the cubic. This is the derivative. But what I'm noting here is that the derivative, so f prime, is positive before this number 5.7, and again after this number 9.312. and it's negative in between these two values, right? So if f prime is positive, that means that f is increasing from 2005 to 2005.78, so like 3/4 of the year through 2005. So let's just say f is increasing for 9 months ish in 2005, and then again it's increasing from 2009 to about 1/3 of the year. So, and again, let's say 4 months into 2009 through 2010. So it's increasing for just 9 months in 2005, right? That would sort of represent this small amount of time right here. And then it's again for 4 months and another year, increasing for a little bit of time here. So we're stopping at 2010. And then f is decreasing between 2005 and 2009, where in this time, of course, is the last few months of 2005 up through the beginning half, the first part of 2009. Okay, so what does this mean in the context of this problem, right? So f, remember, is the gross savings as a percent. So we're saying that is increasing in these two time intervals, and it's decreasing in the intervals between.